Welcome to the edge of the impossible, a world where computers no longer think in ones and zeros, a world that may change everything, starting from medicine to climate predictions, finance, and even reality itself. This is quantum computing, the race for the future. But what is quantum computing really? And why are the world's biggest tech giants and nations pouring billions into it? Let's find out. First, think of your laptop. It works using bits, tiny switches that are either on, binary 1, or off, binary 0. So everything you do, streaming Netflix, checking emails, even this video, boils down to millions of these bits flipping like microscopic light switches. Fair enough? But now imagine a switch that can be on and off at the same time. Isn't it mind-bending? Welcome to the quantum world. These quantum bits or qubits behave very differently from your traditional binary bits. They follow the rules of quantum physics where particles can exist in multiple states at once and influence each other instantly across distances. Sounds like sci-fi, right? No, it's not. This is real. This is happening. But how do these magical qubits work? Let us deep dive. Quantum computers rely on two bizarre principles. Number one, superposition, and number two, entanglement. Now let's understand what is superposition. Superposition allows a qubit to exist in multiple states at once. It's like flipping a coin, and instead of heads or tails, it's spinning midair, being both. And entanglement means two qubits can be connected in such a way that changing one instantly changes the other, even if they are light years apart, as if like they are connected by some invisible thread. Einstein called it a spooky action at a distance. Today is the backbone of quantum logic. But here's the catch. These quantum states are fragile. They collapse with the slightest interference. Even noise or heat can ruin everything.
So room temperature, 300 Kelvin, a lot of jiggling around, a lot of random stuff. We got to get cold to stay quantum, right? And so all our experiments are down in here. These little gold-plated cans are, we can't even see the experiments because they're all inside these cans, but those are little magnetic shields. Down here we're at about 10 millikelvin.
So, quantum computers need to operate in extreme environments, ultra cold temperatures, near perfect vacuums, and electromagnetic isolation. It takes a lot to build the environment for supporting quantum computers, isn't it? So that's why building them is really hard. So the question is, who's winning this race? So let's look at the main players. IBM was one of the first to offer cloud-based quantum computing. Their roadmap? A 100,000 qubit system by 2033. And we are currently in the hundreds. Now, Google made headlines in 2019 claiming quantum supremacy. Solving a problem, their supercomputer took 10,000 years to complete in just 200 seconds. So a traditional supercomputer takes 10,000 years, wherein a quantum computer takes only 200 seconds. China is investing heavily, building quantum satellites, secure communication lines, and even teleporting particles over 1,000 kilometers. And don't forget, D Wave, focusing on quantum annealing, and then there is Intel building silicon based qubits. Microsoft exploring exotic particles called anions, and then we have others in the race. So even startups are racing like Rigetti, IonQ, and Psi Quantum. So then it occurs as to why such an urgency? The simple answer: because the first to master quantum computing may rule the next era of human advancement. But what can quantum computers actually do? Let's look into it in the next section. So, here's where it gets jaw dropping. Quantum computers could crack encryption in minutes. Just imagine. And cracking an encryption would take a classical computer around billions of years. So imagine what that means for cybersecurity and what's the value of such a power. Now, quantum computers can be used for simulating molecules to develop new drugs, materials, or even cure diseases. So, you want a vaccine in days? Refer quantum computing. Quantum computing can also be used for optimizing logistics. Everything from delivery routes to airline schedules, saving billions in fuel and time. Someone wants to predict the financial markets, detect fraud, or model economic systems with unheard of accuracy? Quantum computing might be the answer. Someone wants to accelerate AI by improving neural networks and data handling? Quantum computing might be the answer. So, in short, they could redefine every major industry. But don't get too excited just yet. There are some big challenges. Let us understand them. So, let's be clear. Quantum computers today are not ready for prime time. We are in the noisy intermediate scale quantum, which is NISQ in short, era. So they are powerful but unstable. Their results need correction. Their qubits are noisy, and scaling them is like stacking jelly on top of a jelly. So, what do we need to do then? Number one, we need better error correction, longer coherence times, and scalable qubit systems. Now, then there's a cost involved, right? Building even one prototype will cost millions. So, is quantum computing just overhyped, or are we on the verge of a revolution? Let us look at it in the next section. So, what experts say is we might hit quantum advantage, the point where quantum outperforms classical in 5 to 10 years. Some say even sooner. But no one really knows. Reason? Quantum computing isn't just about faster machines. It's about changing how we compute. It's not evolution. It's a new species of computers. That's a huge thing to manage. And like any new species, It's unpredictable. But then again, it's also full of potential, isn't it? So now the next question is, what does it mean for us as human beings, ordinary people? So you might be thinking, I'm not a scientist, so why should I care? But think about it. Do you use the internet? Your data might need quantum proof encryption. Do you rely on medicine, banks, transportation, or smart tech? Quantum will touch all of it. And here's the best part: quantum computing will open new careers, new industries, and new frontiers for human imagination. Think about this. Your kids might grow up coding qubits instead of bits. So the race is not just between countries or companies, it's between now and the next level of reality. But the big question is, are we ready? So here's a final quiz, okay? And please put your answers in the comment section. So before you go, let's see how much you have learned. Now the simple question is, which principle allows two qubits to remain connected such that the state of one instantly affects the other, even if they are far apart? Option A, superposition. Option B, entanglement. Option C, interference. And option D, tunneling. Comment your answer below and let's see who's really paying attention. Thank you and have a nice day.